Yeah.
Okay.
So do that.
Apparently.
Okay, everyone. So this is Nandini. She's been working on her master's in data science. And as part of that, she's been doing a final year project on personality discussion and the changing language of online text. And she's going to be all about that.
Thank you, Matthew. So, yeah, I'm Nandini, and I'll walk you through my project around personality detection using BERT and the impact of the changing landscape of language. So personality is this combination of behavioral, mental, and emotional attributes that categorize a particular person, right? So personality brings about those changes in patterns of thinking, feeling, and behaving. And personality can be assessed in different ways. So through the course of this study, we've considered the Big Five model to define personality. So the Big Five model defines personality against 5 attributes or traits, which is on the screen, which are agreeableness, conscientiousness, extroversion, neuroticism, and openness to experience. So generally, when we make friends or build relationships in real life, we build it based on how a person behaves or how a person talks to us. So we implicitly understand that that a person's words reflect their personality. So studies have proved that there is an actual correlation between the words of an individual and their personality traits. So based on this hypothesis, researchers have conducted many studies to experiment with different approaches to personality detection using linguistic cues. However, most of these models that are built are almost always trained on canonical language. And like by canonical language, I just mean structured, general language that we speak, right? However, a large amount of data that's available today is not canonical, not structured. It defies the laws of normal grammar. And, it's hard for us humans to keep up with this language. And we can only imagine how hard it is for a model that's built on structured language to keep up with such changes. So when we speak about non-canonical languages, one of the main things that strikes me is social media language. So when we think of social media language, they exhibit a lot of non-canonical traits. It could be emoticons, it could be expressive lengthening of words, it could be slangs, and of course, bad spelling. So why we believe that, that using natural language processing in the domain of social media, especially in the case of personality detection, could be transformative. We still think that the models need to be resilient and sustainable in order for us to actually make that happen. So after looking at existing literature and existing studies, we kind of see that simple BERT as a sequence classifier has not been leveraged for personality detection, and that personality detection models that have been explored in the past have not been tested for their resilience against change in language. So what we propose is to build personality detection classifiers trained on canonical language. So for this, we've chosen the stream of consciousness essays. So the stream of consciousness essays is a data set which is a collection of essays that are written by students mapped against their personality traits. Each of these personality traits are represented by binary values of yes or no. So we propose to build multi-label classifiers and individual binary classifiers using BERT in order to, for personality detection. And in addition to this, we also propose to reproduce the current state-of-the-art results to compare and contrast between performance metrics. And to test the resilience of these models against the change in language, we propose to transform essays into social media language to mimic some nuances of social media and then test the models against these transformed essays. So in our very first method, what we did was we fine-tuned BERT using the stream of consciousness essays to be a multi-label classifier. We see that in terms of resulting performance metrics, right? We see that the individual performance metrics for each of the personality traits are comparable to the ones we've seen before in studies that have been reported. And while the multi-label classifier achieves an F1 score of close to 62% as a whole, we see that the accuracy of predicting the entire combination of personalities is as low as 6%. And this has been something that we've not come across in any of the reports that we've seen so far. I mean, this has not been addressed so far. We've seen multiple multi-label classifiers that have been built, and we've only witnessed their scores on an individual level and not as as a whole. So that's definitely a gap in literature that we've observed. Moving on, we went ahead and built individual binary classifiers for each of the personality traits, which resulted in 5 different classifiers. And again, here we see results that are very close to the ones we've seen before that have used extensive handcrafted features and traditional machine learning methods. However, both the models we've seen so far present performance metrics which are far lower than the ones of the current state-of-the-art results. So in order to understand what is driving this significant difference in results, we kind of went ahead and reproduced their approach. So their approach suggests or proposes to use sentence-level embeddings using BERT, which is obtained from the last hidden layer of BERT. So we've used the CLS vectors. So we've used the CLS vectors that we get from BERT, and they propose to append sentiment vectors of each of the essays to the respective CLS vectors to obtain the input representation. So this particular bit would convert to the input representation. That input representation is then fed to a neural network, which consists of 3 consecutive convolutional layers, followed by 1 fully connected layer to get a multi-label output. The results that we obtain on this front, though, is not only lower than the ones we've seen before in this study, but also dramatically lower than the ones that were reported by the authors. So while this disparity in scores can be attributed to many factors, including randomness and dependence on underlying hardware, this significant difference kind of made us reach out to the authors to understand if there are any nuances in code or any considerations that need to be made to reproduce their results. Now that we had the multi-label classifier and the individual classifier built, we wanted to test its resilience against change in language. For this, however, we did not try to test the resilience of the state-of-the-art model that we were trying to reproduce because of its results. So in order to transform the essays, we chose the method of summarization. So essays from stream of consciousness dataset were then summarized in 2 ways: extractive summarization and abstractive summarization. And each of these summaries were then processed to substitute words with contractions, slangs, acronyms, and emojis as well, resulting in 2 separate test sets, one for extractive summaries and one for abstractive summaries. When they were fed to the multi-label classifier, especially when the extractive summaries were fed to the multi-label classifier, we see a significant drop in scores of some dimensions. And on further investigation, we also found that the classifier was essentially predicting only 2 combinations of personalities out of the 32 possible combinations of personalities. And in the case of abstractive summaries, we see that the again, it's the same case. Instead of 2 combinations, it was predicting 3 different combinations across all inputs, which kind of indicates that the classifier essentially broke, and that the classifier will not be able to handle such transformations on data, and that it's domain oriented or domain dependent. And when it was fed to the individual classifiers, we see that again, there's no change in, there's not a significant change in the metrics. However, on further investigation, we found that agreeableness, or the model for agreeableness, always predicted a positive value for every input, and those of other personality traits were more likely to predict one value over the other, kind of letting us know that they're not stable enough to handle the transformations. So through this study, we have certain key observations that I've taken away actually. So the very first one is that we can use BERT to produce results which are very similar to the ones that that can be achieved through extensive handcrafted features and traditional machine learning models. And especially for applications such as personality detection, where we're using long pieces of text. Another thing is that multi-labeled models that are trained on these essays may not be very reliable in predicting the entire profile of personality of a particular individual, and that there are definitely issues with the reproducibility of the current state-of-the-art model. When we come to the impact of change in language, we say that these models that are trained on these essays are definitely not flexible enough to accommodate these transformations, and are more dependent on the structure and formality of the language. And the observation that some of the performance metrics did not change severely, despite the huge flaw in the classifier, also makes us think of if traditional metrics are even sufficient to reflect the actual abilities of a classifier. And this also creates a serious case for looking at more well-rounded metrics such as Matthew's correlation coefficient. And finally, it's okay that it's not able to perform very well on domain change, but even when we look at how it performs on its own domain, it's not really, it's not really commendable, right? This particular data set has been around for 22 years now, and there have been studies, multiple studies on this data set, and all of them have always reported scores of, say, accuracy between 50 to 65%. And for a classification problem where, the prediction of the presence and the absence of a particular dimension is equally important, an accuracy of 50% is not commendable in any way. And which is why, we think the data set is not good enough in capturing linguistic nuances that are actually required to reflect personality. And this can be attributed to, again, some reasons that, we could think of. One of the first ones is that this particular data set represents personality traits as a binary value, whereas it need not be a binary value. I need not be a complete introvert or a complete extrovert. I think all of us will always belong somewhere in the middle of the spectrum, right? So I think that particular nuance is not captured in this data set. Adding to this, the personality traits that are that are on the data set are resulting from self-assessments, and we found that there are studies that claim that self-assessed personalities are not as accurate as observed personalities. So there could be some. So all we're saying is there could be reasons why it's not able to capture it, and there is a need to investigate if if this benchmark data set is for being the benchmark data set. Yeah. So while the objectives of this research were met, there are some limitations that we have to keep in mind. First of all, the results that we've obtained on this particular study is reproducible on the same GPU configuration and may not be reproducible across different CPU and GPU configurations. And that the transformations are based on a naive assumption that everybody writes similarly on social media, which might not be the case. We've not considered, the fact that some people may not really use contractions or acronyms or emoticons on social media as well. So also, we've not considered how particular personality traits write on social media. So that's also an interesting, interesting study that can be conducted in the future. And in terms of future work, we also plan to test the resilience of existing models that have been suggested in the past to see how they react to social media language transformations. And also, we want to create a new data set, which would not only include essays and self-assessed personalities, but also observed personalities and their corresponding social media logs. We feel that this would open up a lot of opportunities to study correlations between all the four dimensions. So yeah, that's my long monologue, and I can open up the floor for questions.
I think we'll stop the sharing right now, and so we can see also our friends over Zoom. And yeah, and we have a few minutes for questions. So if anyone has a question, either raise your hand on Zoom or just ask it.
Some in the chat.
No, I've been monitoring that. It's good.
I have a question. If I understand correctly, the data set, the Pennebaker data set is the stream of consciousness read by students.
Yes.
Writing,
Yeah.
And you tried to, and this was done in 1999, right? So it was collected, I think, more than 25 years ago.
Yeah.
So you tried to map that to social media language by artificially making it as like Facebook post or something. What?
Yeah. So what we did was these are long essays, right?
Yes.
And we tried to invite certain social media characteristics. First of all, we wanted to shorten it in length, right? So what we did, what we thought of was summarization. But again, we had two types of summaries. The first one was the extractive summarization, which is basically excerpts of text from the original text that can summarize the entire text. So it's not any kind of language that's being generated. And the other form of summarization that we chose was abstractive summarization, which is basically how we would summarize it, not in the same words as the excerpt, but in other words. So there is a certain touch of language generation there. So these two summaries were then processed to, first of all, look for words and substitute them with say acronyms, right? Also short forms. So if there is like a do not, it'll turn it into don't, but that's a simple one. There were also things like, how do you know, which was transformed into very, very short forms of how do you know, and things like that. So so contractions were one thing. We also scraped this particular website, which has a dictionary of slangs and acronyms on the internet. So there were things like about was changed to bout, or ABT, and things like that. Very small nuances. And then we used BERT emoticon, which is basically an emoticon predictor. So each of these essays were then processed through BERT emoticon to generate 10 relevant emoticons, and 3 were randomly chosen to be appended to each of the texts. So that's how we perform.
Okay, I think I'll ask you something off group later on.
Sure,
But I think Gordon has a question.
Yeah, hi, can you hear me okay?
Okay, so that's really interesting. Thank you. So a couple of questions really. So you said the independent measure of people's personality is just self-assessment. Is that right?
Yeah.
And it's just either or. It's like,
Yeah.
okay, so people are just asked things like, are you extrovert or not, something like that?
We don't have the exact questionnaire that was used for the collection of this data set, but yeah, so I'm not sure about this.
Right, because I think that's probably putting a pretty low ceiling on the maximum predictive ability that any system could achieve, right? Because obviously there's pretty sophisticated and more continuous measures of personality. So I wondered if people had tried predicting those more conventional measures of personality using these sorts of techniques at all.
So he was asking if people have tried predicting the scales.
Yeah. There are other data sets that do represent personality as an entire spectrum and as a continuous value rather than a binary value in this that we see in this data set.
Okay, and how successful are those approaches?
Oh, they're much more successful than this. They achieve like accuracies of like 80% and above. And yeah, so
In terms of correlations, it's about 0.3 to 0.4. With a
Okay. Okay, that's encouraging, I guess. Yeah. Okay, cool.
Yeah, I see Adam has a question, but we really do but we really do need to continue with our program. So Adam, I'm sorry, but maybe you could give this. But we thank you so much, Nandini, for your talk.